So, last time we have used our ANOVA analysis to determine what factors are statistically significant in determining a specific outcome. So, we've been analyzing fertilizer and its effect on yield. So, we've seen that fertilizer itself is a parameter that as we vary it, it has a statistically significant effect on yield. And we were able to come to that conclusion based on analyzing the results of in our ANOVA table. If my screen, there we go. And we were able to see this with our, again, you can see the fertilizer results. Our p-value was less than our alpha, which is our 0.05. We were also able to run a post hoc test, specifically a Games Howe post hoc test, in order to see that there is a statistically significant difference between our fertilizer 1 type and our fertilizer, oops, excuse me, let me look at this here. Erase. There we go. 1 and 3 and 2 and 3. So we can see that emerge as well in this data set. So those are kind of some big key takeaways as well, looking at our the p-value in that post hoc test. But now the question becomes, okay, they're statistically significant for these parameters here, but again, is our parameter, fertilizer, is it going to have a large effect, small effect? Like what is it going to actually look like effectively? So one way we can determine the size of the effect on the outcome, so does fertilizer have a large effect, small effect, or medium effect, is by calculating effectively this eta squared value. Eta squared is going to take the sum of squares of the parameter over the sum of squares plus the sum of squares of our error. So we can actually see that basically manifested here. So sum of squares plus this residuals, remember, it can be called error. We saw that in our previous video. So we can actually calculate this. So, and we can calculate it by bringing in essentially a new package. So I can do install packages LSR, and it's going to work. Not like it's going to work, but I can now read in library LSR, and I can bring in basically this eta squared, and actually eta squared is already in the packages as well. So I can take in now my my value here, and what I'm going to bring in is my one way. So I'm going to take in my results of my ANOVA and then calculate the eta squared. So I'm going to do that, and I get a value of 0.14, et cetera, et cetera. Now, one thing I want to kind of point out is that we can double check this. So I can actually take, for example, my sum of squares, so of my effect, which is 6.07, divided by 6.07 plus the sum of squares of my error, which is that, and I should get the same value, or pretty close. So my value is this 0.14. If I look at, to classify whether it is a large effect, medium effect, or small effect, if it's large, it's going to be between, or actually, it'll be 0.14 or greater. So this is just on the border of being a large effect, not a very large effect. If it's between 0.06 and 0.14, it's a medium effect. And if it's 0.01 or lower, it's a small effect. So the fertilizer type, or fertilizer as a parameter, has a large effect on our crop yield. So this is great. This gave us a ton of insight. So as a parameter, we see that fertilizer has a statistically significant effect. Additionally, we saw differences between the particular type of fertilizer as well. And then we were able to, in our post hoc test, and then we were able to run another test and calculate this eta squared value to determine if it's a large effect, medium effect, or small effect. Now, one of the last things that we should probably do before we leave is, well, if I'm running a test, and if I want to maximize the yield of my crop, what type of fertilizer do I want to use? To do that, I mean, you can just do a simple, or not a simple, but let's look back at our F1, F2, F3. So if I look at my, for example, my F1, 2, I can see all of those. I can just look at the mean. I can just calculate that ourselves. So I can look at the mean of this. Then I'm going to do boom, boom, F1, F2, F3, and we can calculate bang, bang. So I can see, well, what type of fertilizer would you want to utilize? Well, I'm going to do fertilizer type 3, right? It has the largest value on average. So if I want to maximize it, I'm going to use that as my, if this was a set of experimental test conditions, I'm going to use fertilizer type 3. So that's what we're going to utilize here. Now, additionally, we've shown that there is a statistically significant difference between 2 and 3. It's slight, but it exists. So when we look at those values, and we can go back here, obviously there's between 1 and 2, these are not statistically significant. So choosing 1 or 2 would mean a difference. But 2 and 3, there actually is a significant difference there. So if I were to say pick a parameter set or an experimental conditions that will maximize, I'm going to pick number 3. So there we go. That's your one-way ANOVA analysis, and really a lot of the questions that we're going to be getting into. Now, we're going to move up in complexity, and we're going to start to analyze now our two-way ANOVA. So what happens when we throw in an additional parameter? Say, for example, and actually how do our equations adjust as well, but what happens when we look at fertilizer and density, perhaps? So we'll see you in the next video. Thanks.